Hey, thanks very much. Thanks so much for having me. By way of introductions, I'm Marcus Pont, and I'm the CEO and one of the founders of Domin Fluid Power. Today, I want to talk to you about how metal additive manufacturing has the potential to revolutionize industries and hopefully give you an example of where we applied that technology in Domin to make significant change. So revolution's a big word, and it has big implications. And indeed, it's been used a lot with metal additive manufacturing. But I believe that there is a great opportunity with additive to bring about a revolution. Revolution, however, often forms and follows a similar path. I want to try and explain what that path looks like, talk about it within the steel industrial revolution, and think about how we can apply that today to get some of the benefits that additive brings. It's hard to know where it will succeed, and it's hard to know where it will fail. And that's going to be determined by great minds of great people around us today in our organizations, and in some instances, people that haven't even heard of additive yet. There are many challenges with metal additive manufacturing, but there are also many opportunities. I don't think to date we've seen the potential that additive has to bring to many different industries, but I think we're just at the beginning. Metal additive manufacturing can definitely be the technology that creates a revolution. It gives you unrivaled design freedom. Not complete design freedom, as we have learned very much the hard way, but definitely unrivaled nonetheless, more than any other process I can think of within metal. That gives us the opportunity to forget everything that we know today and approach technology, products, and applications in a completely new way. But it does require us to forget. With technology revolution, often what happens in the beginning is people apply new cutting-edge technology to existing thinking, existing applications, and solutions that they have already. This is a picture of Iron Bridge. This was one of the first steel bridges made in the world. It was built in 1779, and it has a very short span, and indeed, it's in black and white, and you'd be forgiven for thinking that it's actually a bridge made of wood. And it has the design of a wooden bridge. It's in compression, it's short, it just happens to be made out of steel. This is entirely normal. In many cases, in additive today, we are at this same stage. We have a lot of examples of brackets, filters, manifolds, and they look largely like we're applying new technology to existing ways of thinking today. The bracket at the back looks ostensibly the same as the bracket at the front. It has a flat interface, it's square, it's boxy, but it's applying metal printing to make something that has some of the benefits of printing, but not many. It allows engineers and companies to explore new technology in a safe way. It allows us to take managed risks in understanding the limitations and opportunities of a material. And it's completely normal. It tends to coincide with hype cycles. We all know the hype cycles we've been through with additive. They've been spoken about a lot. And often as we're going up, the first hype cycle, that's when we're applying new technology to existing problems. We've come down that side and we're about to approach coming up the top of the next hype cycle. In order to do that, and in order to do that effectively, there needs to be a time when people throw out the rule book from today, forget the thinking that they have, and start to think of a new paradigm. A man who is infinitely wiser than I ever could be once said that we cannot solve our problems with the same thinking we used when we created them. And in many ways, I think this is a fantastic quote to keep in mind when we think about revolution. But obviously this is hard. It's hard to forget things that you know to be true. Fortunately, it has happened many times before, and there are many examples we can look at in order to help us with this. For metal additive manufacturing to realize its true potential, it is time to throw out that rulebook. And like I said at the beginning, we don't know what the solutions will be. We don't even know today where metal additive manufacturing will have the most impact. That is still to be found out. But if we want to get there, we need to start asking new questions and look for new opportunities. It is time that we threw out the rulebook and prepare to think about the unimaginable benefits that technology can bring. Like I said, it fortunately has been done before. This is Danyang Kunshan Grand Bridge. And it's remarkable, absolutely remarkable. If we went back to 1779 and told those humble bridge builders that one day there would be a bridge where we're using steel like rope that was spanning a waterway that's 165 kilometers long, they would think that we're insane. They would say, we know how to make bridges. We've been making bridges for thousands of years. We know what the limits are. It's not possible. Fortunately, through much innovation, invention, failure, success, and trying new things, a generation of people were able to push the boundaries of the steel that we had, the technology revolution that was steel, and develop solutions to problems that we didn't think were possible. There's a fantastic book called The Origin of Wealth, written by a gentleman called Eric Beinhocker. And he talks about evolution of technology and how through innovation and through those attempts at finding solutions, what happens is we explore areas of instability. And eventually, after a period of time, we ending up on a solution that gets replicated throughout the world. This is an example of that. This bridge looks like many suspension bridges. It looks the same as everything else. And what we've done at Domin is try to find those new technology stable solutions in different areas. We don't know what that will be with additive, but I've somewhat given the game away that we certainly think that hydraulics are going to play a part in that. Hydraulics are everywhere, absolutely everywhere. Their ability to transmit power, control force, control motion, and operate reliably under incredibly high pressure, heavy loads, and harsh conditions means that they're an integral part of a huge variety of applications that exist in many industries. Hydraulic systems are essential for accurate and repeatable process control within industrial machinery. They're used within injection molding, die casting, machine tools, and many more. Hydraulic systems in aircraft require compact, power-dense application in order to control steering, lift, brakes, landing gear, many more, and they operate in incredibly harsh conditions. And in automotive, they're used with power steering, brakes, and everywhere. We also have images here of construction, where the conditions are incredibly harsh. They have to be used reliably, repeatedly, and to date, they're relying on technology that was developed 70 years ago. Hydraulics form a central part of almost all the industries that we rely upon in order to give us the lives that we live today. So they're great. It's a great thing. But because they are everywhere, they have a big impact. McKinsey carried out a study last year titled Preparing for the Imminent Revolution in Fluidic Systems. And it's not often I find myself vehemently agreeing with a management consultancy firm, but this was one of those occasions where I did. During that study, they found that fluid pumps account for 15% of all the energy consumption within the EU. 15%. It's a huge number. It's not aerospace, it's not automotive, it's not construction, it's hydraulics. Something which connects all those industries. It is everywhere and it's nowhere at the same time. You don't see it, you don't think about it, but it has a huge impact. 15%. But does it need to be as much as that? Energy is really important in order to promote human prosperity. We've seen an almost direct correlation between the amount of energy that we've used through the years and human prosperity. And so it's important that we keep thinking about how we promote successful and effective use of energy. In 2012, Oak Ridge National Laboratory, a US research institution, carried out a cross-sector, cross-industry study looking at everything throughout the supply chain of hydraulics, looking at how they're manufactured, how they're used, and within it, they discovered that hydraulic systems on average, are only 23% efficient. Now, what does that mean when we think about 15% of all of EU energy? What it equates to is 4,300 petajoules of energy that is wasted within hydraulics within the EU each year. Now, I don't know how big peta is actually. It's a number that I don't have a concept for. But for that reason, I know it must be big. To give you a little bit of context, it's the equivalent of about 82 million homes within the EU. 82 million. One of the questions I've asked myself over the last decade is why it's so big. And often when we have big questions, we look for complicated solutions, but I think it's actually quite simple. I think it comes down to the same old story of human fallibility. And I think it's a really common thing. I think it's just that the human instinct doesn't allow us to quickly and accurately estimate compounding numbers. So a great example of this is if I were to give everyone in this room a penny today, and you doubled it every day for a month. In just 30 days, you'd have £5.5 million, which is a lot of money when you start with a penny. And the same thing's happening within hydraulic systems. Most components within the system are greater than 90% efficient. But you have a pump, a motor, valves, actuators, accumulators, and you add all these things together and you very quickly end up with a system that operates at only 23% efficiency. That means we waste a huge amount of useful energy, a huge amount. And the question that we need to ask ourselves is, what do we do about it? Today, that control of motion is not intelligent, it's not smart, it's not effective with its use of energy. And there's a once-in-a-lifetime opportunity to change this. And we think additive is going to do that. There's an opportunity to increase this efficiency from 23% to 90%. And the technology that we've developed with additive allows us to do that. That would mean we'd save the equivalent of 70 million homes per year worth of energy. And we've done that by asking a new question. We come back to our friend Albert Einstein. And instead of asking ourselves the question, how efficient can we make the system? We completely reframed the question and said, well, how much energy do we need in order to do what we want to do? I'll give you a quick example of this, but it can be applied to many, many different situations. Think of a forklift truck loading and unloading a lorry, storing boxes in a warehouse. You start off with the box on the lorry, you take it off, you put it on the shelf, you take it back down, and you put it back on the lorry. During that change of motion, the box has not changed its energy at all. That should be a zero energy movement. But up to now, we use energy to drop it, to pick it up, to move it, and repeat it. That doesn't have to be the case. There are all sorts of examples throughout the world where the opportunity to think about use of energy can change the question. Steering aeroplanes is exactly the same thing. And this can give some incredible outcomes. And as yet, you've seen nothing to do with additive at Domin. But we'll have a look now. We've been rethinking the art of the possible. We've thrown out the rule book and we've asked a new question. We've developed technology in many, many areas that allows us to have smart, intelligent, and ultra low energy control of motion. I just want to share one example with you today. The example that we can see on the screen here would not be recognizable to people who are experts in the industry. If I removed the car from this picture, it would be really hard to guess that this had anything to do with automotive. Indeed, this is a fully active suspension system. You can't see any springs, you can't see a damper. It doesn't look anything like what classic suspension systems look like. It would be unrecognizable to suspension designers. But by asking a new question, we've been able to find a new solution. In fact, it hardly even looks like it's additive. It doesn't look necessarily like it's a classic additive part. But within it, and I don't think this is giving a great gauge for scale, but it's about this size. The main body of it is about that size. Within that product, we have 7 high-performance hydraulic servo valves that would traditionally each be this size. We have 2 hydraulic, highly efficient pumps. We have the ability to almost infinitely variable spring rate. We have the ability to have an almost infinitely variable damping rate. And we're able to put full energy into and out of the system. And that is all thanks to asking a new question and using additive to solve the solution. We think we've found that stable position with additive in hydraulics, where it's the integration of functions together to solve the questions of energy use that will give us the greatest outcome. Now, I've been talking about energy, I've been talking about additive, and now I'm talking about suspension. What does that have to do with energy? With our active suspension system, you can increase the range of an electric SUV by 10%. Now that seems almost impossible. And one of the great things that I've discovered over the last 10 years or so, looking at new technology, is once you find something great, it so often unlocks other opportunities, and you end up in these virtuous circles of benefit. Quite often this can be seen when you make something lighter. You can then make the housing that holds it lighter, etc., etc. So how is this possible? Well, within driving, the majority of the losses when you're moving come from aerodynamic losses, come from rolling resistance, and come from weight. With the suspension system we have, we can take up to 100 kilograms off a car. We can reduce the rolling resistance such that it adds 5% to the range of a vehicle. And at the same time, we can reduce stopping distances, increase acceleration, and increase performance around a track. We can also dynamically change aerodynamic losses in a way that means we have the ability, once we put all those things together, to finally increase the range of an electric vehicle by 10%. This is something that we're having great commercial traction with and shows some of the opportunities that metal additive can bring if you rethink how to phrase a question. We don't think it's going to be easy, but we are 100% convinced that additive manufacturing is going to create a revolution. It's just a matter of time before we get there. Thank you very much for listening, everybody. I hope that you enjoyed it.